Hi, today we will start talking about the human-computer interaction, and we start with what does interaction mean and what are the interaction paradigms. In this lecture, we're gonna discuss how interaction has developed, the innovation, what are the computing environments, how do we analyze the interaction paradigms, and what are the interaction or the different interaction paradigms that are out there today. What is an interaction paradigm? Interaction paradigm is a conceptual framework that serves as a model for thinking about the human-computer interaction. How, where, and why humans use computers, and how those usages and technologies manifest themselves in order to help us interact. It all started back in 1945 with some devices that tried to make interactions between humans and machines. The first of them being the Mimics, which is a device in which an individual can store all his books, records, and communications, and which was mechanized, of course, and not electronic, so that it may be consulted with exceeding speed and flexibility to get information. We also had some manifestations of computing systems in the 60s, like the online system, which included mice and keyboards. The mice were the pointing devices used to point to screens, and this was the first human augmentation system in which the humans, interact with machines. We also had the online interactive vicarious expeditor and responder. It carries out communications, sends out information, and receives information. This was in 1968 also. And nowadays, we are talking about the ultimate, which is creating realistic products using 3D printers and obtaining a realistic look at products using 3D monitors, for example. We have three computing environments that we can talk about. The first of them being the physical computer environment, and then we have the social and the cognitive. Physical, it started with mainframes back in the 1940s. Mainframes were very large as a football field, very noisy, consumed lots of powers, and interaction was hard with them. Then things developed. Now we have mobiles and we have laptops and iPads, and our design now concentrates on safety, efficiency, space saving. Our workspace can be set anywhere. We can also work with different lighting, backgrounds, noise is minimized, and also pollution. Social computing is an environment where people use computers together. It affects the way people use computers. For example, mobile computing can be used anywhere, while desktop computing has to be used in one place. Or if we are using a network, we have to collaborate. So it is affected by the social environment. And we have the cognitive computing environment. Cognitive computing environment it's an environment where people share the computing structure. They work together, but we have to take things into consideration, things such as age, disabilities, degree of technical knowledge, degree of focus, and cognitive stress. To analyze interaction paradigm, we have what we call the 5W plus H analyzation. 5Ws stand for what, where, when, why, and who. And the H stands for how. So the what and how talk about the physical and virtual interface is the what. Physical components are the how. The where is where the component is, the network, the embedded desktop, mobile, or the wearable. And when is how the availability of data. Who, user, who and why, who uses the system and why is the system used. Now, some of the interaction terms that we might come across: information space, where is our information saved? What is our interaction architecture, which is the structure of the interactive system? What is our interaction mode? Do we deal with it visually or auditory or using our senses? What is the interaction paradigm? Is it physical? Is it virtual? Is it perceptual? Is it cognitive? Where is this interaction? The interaction space is where this interaction takes place. The interaction style, how is this interaction performed? Is it using the command line or using the graphical user interface or using speech? And workspace is where the place, where is that interaction taking place? Now we're going to talk about some of the interaction paradigms that are used in our world. We have large-scale computing, personal computing, network computing, mobile computing, collaborative environments, virtual reality, and augmented reality. Large-scale computing, we use large mainframes, large computers. This is the what. How are they accessed? They are accessed remotely by alphanumeric terminals, for example. This constitutes the how, because all the computing power is in the mainframe itself. So the systems that access it need not be intelligent systems. They can be dumb terminals. Okay, where is it used? It's used in large government agencies or large institutions such as universities or places like Wall Street. This is the where. When is it used? All the time. This is the where and when. Who uses it? Usually it needs highly trained individual to program and maintain, and they are very expensive. So large-scale computing, things like supercomputers. Personal computing, the interaction architecture started with the desktop environment that was created in the late 70s, early 80s. It is used by a single user. It has a keyboard and a pointing device. The power, the computing power is in the computer itself. It is available everywhere and can be accessed and used at any time. So you can have it in your house, in your office, etc. But it's not mobile. It's used for a wide variety of reasons and by a wide variety of users. It can be used by engineers, teachers, everybody, students. We also have public personal computing, things like ATMs and data or information kiosks. Networked computing is a computing that needs collaboration in work environment. People need to collaborate. So we have networks. We have local area networks, LANs, wide area networks, WANs, mid-area networks or metropolitan area networks, MANs, and the internet. So people use this communication to work together. Each has his own computing power and they collaborate. Access to network can be done from any place at any time with remote access. This is the concept of, it changed the concept of where and when. So it doesn't have a certain where or when. Used by anybody for many purposes such as e-commerce. The internet started in 1969, or the networking idea. We started with, they started using the LANs, the WANs, the MANs, and the PANs, and they used wired and wireless communications to perform networking. Mobile computing, the word mobile means that I can use the device at any place, at any time. And they are mobile. This is the definition. Things like laptops, tablets, game players, MP3s, PDAs, cell phones, they are computers, they have computing powers, and we can use them in anywhere at any time and can be used for almost anything and by anyone. This is the who and the why. Collaborative environments. Collaborative environments, members interact with each other and share resources. For example, in your Canvas, we might create a collaboration where a group can work on a project and each of them will share information, and then the information can be collected by one of the team and formatted and edited to create the result. Collaborative work can be through computer-mediated communication or can be using computer-supported cooperative work, and can be used by, for example, employees, customers, design teams, students, etc., who need to work on one project and in one space and share a data space. Collaborative environments can be synchronous or asynchronous. Synchronous at the same time, like video conferencing or chat rooms or instant messages or whiteboards, and asynchronous using discussion groups or emails or bulletin boards, etc. And it also can be, if it's remote, if it's face-to-face, we can use smart rooms, projectors, smart boards. But we share the information, and each of us can use his piece of computing technology to share the information. Virtual reality, it integrates the computer functionality with the real world. Okay, so it creates objects from a human perception. It has two types: immersive, non-immersive. Immersive, it will create a convincing illusion that you are in that environment, and this is like when you wear a virtual helmet. You will be as if you are immersed in the virtual environment. Non-immersive, watching 3D presentations, or watching or working with 3D objects or programming 3D objects. Virtual reality is used in engineering, in education, in psychology, in simulations, in training, mission-critical domains, and also in medical training and medical usages. Augmented reality is both real and virtual, the integration between real and the virtual objects, and it augments the user's perception and experience. Criteria for augmented reality: the virtual information must be relevant and in sync with the real world environment that we are trying to discover things about. It augments our knowledge and understanding of specific spaces of things. For example, if we need to see how the electrical grid is placed in a building, we can use augmented reality, or if we want to use, if we want to see how piping system, etc. Embodied virtuality means that I embed the computing power into the different devices, and we have three types. We have the pervasive, or what we call ubiquitous, and we have the invisible or transparent computing, and we have also wearable computing. Now, the embodied virtuality depends on two things, or two parameters: the location and the operation. The location might be portable or fixed, the operation manual or automated, and so they can be, we can have four choices: portable manual, manual fixed, portable automated, and automated fixed. For example, portable manual devices such as cell phone, they are portable and manual. We have to make if I want to make a call, I have to press send, I have to put in the number. We have manual and fixed, things like ATMs and information kiosks. We have portable and automated, things like car transceivers when you go through toll roads. You don't interact with it. It sends and receives information automatically, and it's portable. It's not used in one place. And automated and fixed, it is automated, but the position is fixed. Things like sensors, alarm sensors that work with intruders, etc. Ubiquitous computing, or Ubicom, is a concept in software engineering and computer science where computing is made to appear anytime and anywhere. It's in contrast with desktop computing. Computing power can be put into devices like cameras, video recorders, musical instruments, to help them fulfill their potential at the best possible level. Invisible, you put computing power into, for example, cars, braking systems, gear systems, cars that drive themselves. They are invisible to us. The computers are invisible. We don't see them, but we see their results, the result of their work. And wearables is computing powers that we wear, like the smart watches that perform computing with while it's worn by humans. Wearable computing integrates three spaces: the information and the interaction and the workspace, all in one thing in your hand. This is just showing the different embodied virtuality and their characteristics. Okay, with Ubicom, sometimes they are manual. With Invisible, they are not manual because the user does not interact with them. Many of the wearable components allow manual control. Automated, sometimes the Ubicom is automated, not manual. Invisible system takes care of all the computer functionality. Some of the wearable components interact automatically with embedded sensors. Fixed, some components are embedded and in a fixed place. Also invisible, they are embedded. In wearable, some components are use situated sensors. For example, if I'm doing a body science scan, I should have sensors or the wearable weared or situated in a certain place. Portable, some of the Ubicom devices are portable, some of the invisible devices are portable. Wearables, most of the components are portable. This is the end of chapter 1. Thank you very much for listening.